हम्म यहाँ पे so we are today's session is dedicated to learning dimensions only, right? We will learn every aspect of dimensions. Okay, so एक मिनट और रुकना, एक मिनट और। हाँ, चलो। So dimensions में what are dimensions? First, can you see this? I am sharing this with you, right? Yeah. So it says the powers to which the all of you are aware about fundamental quantities, right? Vihan, Manogna, Krisha,
Yes, sir.
Ishan,
Yes, sir.
Anya,
Yes, sir.
Khyati. Yeah.
Sir.
So let's first try to understand what are dimensions. So dimensions are the powers to which the fundamental quantities must be raised in order to express the given physical quantity. So what does this mean? I repeat it again. The powers to which the fundamental quantities are raised in order to express the given physical quantity, right? So for example, suppose the physical quantity which we have is say volume. Okay. Now, वॉल्यूम का यूनिट क्या होता है? व्हाट इज एसआई यूनिट ऑफ वॉल्यूम?
मीटर क्यूब।
Meter
मीटर
cube.
क्यूब।
Meter.
एसआई यूनिट ऑफ वॉल्यूम इज मीटर क्यूब, राइट? सो लेंथ के तीन डायमेंशंस मल्टीप्लाई होते हैं तब। सो if I write it in dimensional formula, it will be length to the power 3. So it has three dimensions of length. Understood? Volume has, when length is raised to three dimensions, we call it volume, right?
Yes, sir.
So this is what is the dimension. For example, let's see one more example. For example, we have force. All of you, please pay attention. Don't write anything, pay attention. Force का formula is mass into acceleration. Force क्या है? Mass into acceleration. Mass is capital M. What about unit of acceleration? Unit of acceleration is meter per
per
second square.
Meter per second
So it
square.
is length upon t raised to 2 meter per second square is मीटर पर सेकेंड स्क्वायर का यूनिट क्या होता है? लेंथ अपॉन टाइम टू द पावर 2. यस और नो ऑल ऑफ यू?
Yes, sir.
यस सर।
Yes,
So
sir.
now
Yes, sir.
if I write the dimensional formula of force, it is m to the power 1 into L to the power 1 into t raised to minus 2, right? So it has one dimension of mass, one dimension of length, and minus two dimensions of time. Understood?
Yes, sir.
Yes. Sir,
So
Yes.
these
how is
powers,
time raised to minus 12?
अरे यार मतलब क्या ये क्या पूछ रही हो तुम? तुमको इंडेक्स नहीं पता है बेटा? कितनी बार एक ही चीज को तुमको घिसाएंगे बे? बताओ, 1/x को x पावर -1 लिखती हो कि नहीं है तुम?
नहीं, वो तो
पहली
समझा
बार देख
कि
रही हो? हाँ तो
माइनस
फिर
किया, लेकिन
हाँ,
टाइम को स्क्वायर कैसे करते हैं?
अरे मतलब दो बार टाइम सेकंड स्क्वायर आया कि नहीं आया?
तो मतलब
एक
ऐसा
सेकंड, हाँ ठीक है,
दो
मैं समझ गया
सेकंड है।
तुम्हारा चाल। सुनो सुनो, 2 सेकंड नहीं है, सेकंड मल्टीप्लाइड बाई सेकंड। तो सेकंड का क्या डायमेंशन क्या है बेटा? सेकंड को कैसे लिखते हैं फॉर्मूला में? इसका फंडामेंटल क्वांटिटी क्या है? टाइम है।
टाइम।
तो उसको रिप्रेजेंट कैसे करते हैं बेटा? टी से रिप्रेजेंट करते हैं। समझ आया?
हाँ,
तो टी इंटू टी क्या हो गया? टी स्क्वायर हुआ कि नहीं हुआ?
तो 2 सेकंड है तो 2 × 2 4
कौन
मिलेगा
बोला
मुझे।
2 सेकंड को? 2 सेकंड नहीं है,
अच्छा।
सेकंड इंटू सेकंड है ये। 2 सेकंड का मतलब 2 × s होगा। इसका कोई डायमेंशन होगा क्या?
ओ, समझा अभी।
कुछ भी। अरे भाई मल्टीप्लाई है ये बेटा, ये कांस्टेंट है। इसमें एक ही डायमेंशन है टाइम का, देखो टी। समझी तुम?
हाँ सर अभी
पक्का?
हाँ सर।
हाँ, सपोज करो सेकंड क्यूब होता तो क्या लिखती तुम बताओ?
टी
टी
इंटू टी
टी
इंटू टी
इंटू टी, तो ये हो जाता टी पावर 3, मतलब 3 डायमेंशंस ऑफ टाइम इन्वॉल्व। समझी?
यस सर नाउ
हाँ हाँ, मैं सोचा तुमने मुझसे ये पूछा कि 1/t² को t-2 कैसे लिख दिया, इसलिए मैं डांट।
नहीं नहीं।
ये सब मत पूछना गलती से भी मुझसे। चलो एनीवेज, ऑल ऑफ यू, बेटा ये समझ में आया सबको हाउ टू राइट डायमेंशंस?
Yes.
लेट्स डू वन मोर एग्जांपल एंड देन यू कैन मेक नोट्स। इधर देखो, ऑल ऑफ यू प्लीज पे अटेंशन। लेट्स राइट मोमेंटम। ठीक है, मोमेंटम इज
Possible.
मोमेंटम इज गिवन एज मास
Mass into
into
velocity.
velocity. ठीक है, it's given as mass into velocity. What is unit of mass? kg.
kg.
What is unit of velocity? Meter
ms
per
minute.
second. Please pay attention, all of you. बहुत, this is very important, right? kg mass is represented in fundamental quantities as m, right? M to the power 1 multiplied by meter is represented in length, length to the power 1. Time is represented in, second is represented in t, and this is t to the power 1. So when we write dimensional formula, it is m to the power 1 into L to the power 1 into t to the power minus 1. So it has one dimension of time, one dimension of length, and minus one dimension of length. I hope all of you understood this.
Yes.
यस सर।
Yes,
आन्या
sir.
कहाँ है? आन्या,
यस सर।
तुमको समझ आया कि नहीं आया?
यस सर आया।
पक्का?
यस सर।
हाँ, तो start writing it from here, right? You have already written that these are examples of dimensions, right? How to write dimensional formula. These are examples of dimensional formula. ठीक है, लिखिए।
डन।
Done, sir. Done, sir.
डन सर। डन सर।
सर you're muted.
Write this one, momentum. Now I am giving you a next work to do. ठीक है, torque. Torque is given as R cross F, right? This is cross product of R cross F. R is obviously the position vector. R is the position vector of the point of application of force. So you remember it as position vector as of now, right? So its unit will be what? Newton meter. Now please write dimensional formula for torque. All of you try writing it. Try writing dimensional formula for torque.
Sir, Newton meter is n minus n.
n माइनस m नहीं है बेटा, न्यूटन और डैश लगा के मीटर है वो,
Oh,
ना हाइफन है वो बीच में, ठीक है?
Sir, will you explain what is torque?
नहीं, it is only r cross f. Unit is Newton meter, ठीक है? And you have to write, you know what is Newton, you know how to write mass का formula, so write dimensional formula.
sir.
हाँ बेटा,
सर टॉर्क का फॉर्मूला फोर्स इनटू डिस्टेंस भी होता है ना?
वो r वही है, देखो वहां पे क्या लिखा है, पोजीशन वेक्टर होता है, पोजीशन वेक्टर का यूनिट क्या होता है?
1।
मीटर, वन
हाँ
नहीं मीटर।
हाँ
पोजीशन वेक्टर, पोजीशन किस में दिखाते हैं बेटा हम लोग? मीटर में दिखाएंगे ना।
हाँ
मेजर किस में करेंगे? पोजीशन को मीटर में करेंगे।
हाँ
तो
हाँ
इसीलिए उसका फॉर्मूला क्या हुआ? न्यूटन मीटर हुआ उसका एसआई यूनिट,
हाँ,
ठीक है? तो अब एसआई यूनिट पता है तुम्हें, यू हैव टू राइट डायमेंशनल फॉर्मूला, दैट्स इट। टॉर्क
ठीक
क्या
है।
होता है, कहाँ से आता है, कौन है, मुझे इससे कोई लेना देना नहीं,
सर
ठीक है?
टॉर्क मोमेंट।
अभी अभी कुछ नहीं बोलना है, ये सब
यस सर,
टैबू है ये
यस।
बोलना अभी, है ना? बिल्कुल नहीं, ना मुझे
यस
सुनना
सर,
है ना तुम्हें बोलना है।
यस सर, यस सर।
वो दिशा ही पकड़ लेगा गलत।
Sir,
हाँ बोलो।
so what is F
एफ इज
here?
फोर्स, एफ इज
Then,
फोर्स।
sir, you written as N dot M. Newton and
कौन हो तुम?
of
कौन हो तुम?
Pranav,
हु आर
sir.
यू?
Pranav.
प्रणव, इट इज न्यूटन इंटू मीटर, इट इज न्यूटन इंटू मीटर, राइट?
Okay,
यू
sir.
अंडरस्टूड दिस एसआई यूनिट नाउ?
Yes, sir.
हाँ करो। You have to write dimensional formula. You know how Newton is given. You know how mass force, what is force ka, how force is given. We have just done it, right? In the previous example.
Yes.
Here,
sir.
mass into acceleration. We wrote dimensional formula for force, right? So you also write dimensional formula for force multiplied by length. Do it quickly, all of you.
डन।
Hmm. विहान, कृषा, नीलाभ,
सर।
नीलाभ का हो गया, विहान हुआ बेटा?
यस सर।
दोनों विहान।
Yes,
आन्या,
sir.
what is your answer, Anya?
Sir, I'm not able to understand how will we write Newton as.
फोर्स को पता है फोर्स कैसे लिखते हैं?
No, sir.
Remove this. You know how to write force.
Is it
Second example, check for today's only. We did second example. तुम लिखते समय सो रही थी बेटा?
no, sir?
फिर अभी तो लिखवाया है फोर्स, तो फोर्स का डायमेंशन लिखो। व्हाट इज यूनिट फॉर आर? मीटर होता है। तो हाउ डू वी रिप्रेजेंट इन डायमेंशन फॉर्मूला? L power 1.
Yes, sir.
नाउ डू इट। ईशान, नोटेड? धीरेन्द्र रेड्डी, लिखा बेटा तुमने?
यस सर।
ओके। ख्याति, व्हाट इज योर आंसर?
Sir, my answer is M to the power 1
हम्म,
dot L to the power 2 dot T to the power minus 2.
e to the power -1.
Minus
So
2.
-2. Okay. So it has one dimension of mass, two dimensions of length, and -2 dimensions of time. How many of you got the same answer?
Sir, I got.
Sir, I got the same answer.
Sir, I
Okay.
Sir, I got.
Okay.
Sir, I
Okay.
wrote multiplication sign instead of that.
बहुत बढ़िया, शाबाश. Pranav, you understood this?
Yes, sir.
Okay. So force is what? Force is dimension formula for force is what? We have just found it, right? It's mass into acceleration. This is R, right? R is again L power 1 into mass का क्या है? It's M power 1. What is the dimensional formula for A? It is L power 1 into T power minus 2. Write the SI units, segregate it, and then this is L power 2, M power 1 and T to the power minus 2. आया समझ में सबको? हाँ ना बोलो भाई जल्दी से.
Yes, sir.
Yes,
Isha,
sir.
Yes, sir.
Pranav,
Yes,
you
sir.
want to ask something? Pranav,
No, sir.
why have you raised your hand?
I forgot to lower my hand.
Okay. Mishika, तुमको समझ आया बेटा?
Yes, sir.
Anya, now you are able to solve or not?
Yes, sir. Now I understand.
Okay. Okay. So this was how we write the dimensions, right? अब आते हैं वापस से back to our mind map. So you can see here its area is two-dimensional in length. So we know area how we can write it, right? So in this example, all of you see this. There is some physical quantity Q. It is dependent on M, L, and T. M power alpha, L power beta, T power gamma. So it has alpha dimensions of M, beta dimensions of length, and gamma dimensions of time. I hope all of you understood this, right?
Yes, sir.
Now,
Yes, sir.
now it says applications of dimensional analysis. क्या बोलता है देखो, to find the unit of a physical quantity in a given system of units. To find the unit of a physical quantity in a given system of units. So, unit कैसे लिखोगे किसी का भी? How will you write the unit? So you should be aware about how a particular, for example, let's write density. ठीक है? Let's write density. We don't know the unit of density, but we know unit density is represented as mass upon volume. All of you, please pay attention. Don't write.
Yes.
Density is known as mass upon volume. Yes or no? All of you are aware of this or not?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
So how will we write mass? Mass is written as capital M. How do we write volume? Volume is
L.
L to the power 3, right? So it is M power 1 into L power minus 3. Mass is, unit of mass is kilogram. Unit of L is meter. So it is kilogram meter per meter cube. Or you write it as kilogram per meter cube. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So that is how we write the unit of a given quantity. Example के लिए लिखो ये वाला. Example. ये किसका example है? How to write unit of
Dimensional.
a नहीं, unit of a given physical quantity. It's just an example. हाँ नीला बोलो.
सर वो वो m टू द पावर 1 लिखना जरूरी है क्या, या सिर्फ m लिखा तो भी चलेगा?
चलेगा.
ओके.
Done, sir.
Done, sir.
Done, sir.
हम्म ठीक है. Now the next application. This was one of the applications of dimensions. Now it says, please pay attention. Don't write anything until and unless I say to write. Okay, I say you to write. Please pay attention. It says to find the dimensions of a physical constant or coefficients. To find dimensions of physical constant or coefficient. Now, I'll explain this to you. So, applications of, we are learning applications of dimensional formula. Of dimensions. इसमें क्या था? Second application is to find the unit ना? क्या लिखा था वहाँ? हाँ, to find dimensions of, obviously dimension मिलेगा तो वो भी मिल जाएगा. To find dimensions of physical constants और coefficients. प्लीज ध्यान से सुनना. हाँ, ऑल ऑफ यू. कृषा समझ आ रहा है बेटा?
हाँ सर.
ठीक है. To find dimensions of physical constants or coefficients. For example, I'll give you two examples, okay, for this. Please pay attention. Don't write. I'll give you time to write. Now, in gravitation, all of you are aware that we have gravity which pulls us towards the earth. Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes.
So
Yes.
here are two masses. Here we have two masses, mass m1 and mass m2. And the distance between these two masses is r. The distance between these two masses is r. Right? The force of attraction, all of you please pay attention. The force of attraction between these two masses is given as, is proportional to product of the masses and inversely proportional to the square of the distance between the masses. The force of attraction between these two objects, right, or the force with which these two objects will attract each other is proportional to product of the masses and inversely proportional to square of the distance between the masses. All of you understood till this point? Yes or no?
Yes, sir.
Sir, how is it
Yes, sir.
inversely proportional to r square?
मैं समझा नहीं तुम्हारी बात. तुमको इनवर्स का मतलब नहीं पता है या तुम मेरे से पूछ रही हो कैसे आया ये?
हाँ, कैसे आया?
नहीं नहीं देवी, नमस्ते. हम ये सब नहीं समझते. हमको पता ही नहीं कैसे आया. ये होता है, ये पता है बस.
अच्छा.
हाँ,
ठीक है.
ये कब पढ़ाऊंगा? जब ग्रेविटेशन आएगा ना बेटा, तब पढ़ाएंगे.
अच्छा.
कैसे आया वो ग्रेविटेशन में पढ़ेंगे. अभी हम क्या है, अभी हम सिर्फ जो चीज सीखना चाह रहे हैं वो ये सीखना चाह रहे हैं ये कांस्टेंट का हम डायमेंशन कैसे निकालते. तो एक चीज हमें मालूम है पहले से कि फोर्स इज प्रोपोर्शनल टू m1 m2 एंड इनवर्सली प्रोपोर्शनल टू स्क्वायर ऑफ द डिस्टेंस बिटवीन. ठीक है. हाँ, तो ये तो 11th वालों को भी नहीं पता होता कि ये कैसे आया. जब उस सब वो लोग पढ़ रहे होते हैं डायमेंशंस जब, तो उनको भी नहीं पता होता. ग्रेविटेशन में पता चलता है कैसे आया. ठीक है. हाँ, तो ध्यान से सुनना बेटा. तो अब द डायमेंशन constant, the constant here is, always remember whenever we have some proportional thing, right, say y is proportional to x, so there will always be some constant associated with it, right. एक कुछ constant हमेशा होगा. You know this or not, all of you? Do you guys know this proportionality and then
Yes.
how it is multiplied?
sir.
There is constant. Yes or no, all of you?
Yes, sir.
Yes.
Sure. So for example, suppose I say कि let's say a is proportional to b. Suppose I say this, right? And then to make this proportional sign go, or to make a equal to b, we multiply it with, again, we find it using some experiment. We multiply it with a constant 2b, right? Let's say, right, the constant is 2 here. So we can easily say that a is proportional to b in this case, and the constant here is 2. I hope all of you understood this. समझ आता है ना बेटा सबको? Proportional, how to remove proportionality sign?
Sir.
Yes,
Jagannath,
sir.
Anvi,
Sir.
Khyati.
Sir.
Okay. So we have y is equal to, Abdul, तुमको समझ आ रहा है बेटा?
Yes, sir.
Okay. So y is equal to, so I don't need this. हाँ नीला, बोलो बेटा.
सर एक्चुअली वो मुझे समझ में नहीं आया प्रपोर्शन साइन कैसे हटाते हैं.
अच्छा, एक बात बताओ नीला, मेरे पास y इज इक्वल टू, मान लो ax दिया हुआ है, या a की जगह तुम कुछ और लिख लो, तुम लिख लो bx, कैपिटल B इंटू x लिख लो. b इज अ कांस्टेंट. ठीक है
हम्म.
नीला,
हम्म.
b इज अ कांस्टेंट.
हम्म.
तो y इज प्रोपोर्शनल टू x हम लिख सकते हैं.
ओके.
ये कांस्टेंट का कोई डायमेंशन तो है नहीं, मुझे तो अभी तो नहीं पता डायमेंशन है कि नहीं है मेरे को, पर ये
हम्म.
कांस्टेंट
हम्म.
था. ठीक है,
हम्म.
तो कांस्टेंट था इसलिए मैं y को x के प्रोपोर्शनल लिख सकता.
ओके.
ठीक है, तो अगर ये ऐसा होता, मान लो c अप इज प्रपोज c अपॉन x है मान लो, तो ये इनवर्स में है, तो y इज इनवर्सली प्रोपोर्शनल टू x, अगेन वेयर c इज अ कांस्टेंट.
कांस्टेंट.
गॉट इट? All
हम्म.
of you, anybody is having any doubt in this? I may understand that this might be your challenge in understanding proportionality and its constant. If anyone is having any challenge, please ask.
No,
So,
sir.
sir, to make it what? How do we call that?
Sorry.
To make it proportionate, we have to remove the constant first.
Yes.
Okay.
ठीक है. और to remove proportionality sign, to make it equal to, we should multiply it to some constant which we get after doing some experiment or doing some data analysis. Got it?
Yes, sir.
Good. So now the proportional sign, the constant here is capital G multiplied by m1 m2 upon r square, right? Because it was proportional to product of the masses and inversely proportional to the square of the distance between them. So F is equal to G m1 m2 by r square. Here G is a constant. This constant has a unique name, right? And this constant is known as universal gravitational constant.
यूनिवर्सल ग्रेविटेशनल कोएफिशिएंट.
Constant or coefficient. ठीक है? It's universal gravitational constant. Understood, all of you?
Yes, sir.
Yeah, everybody
Yes.
understood till this point. Please say yes or no. All of you.
यस.
Yes, sir.
Anyone is having any doubt, you can ask. Jagannath, why have you switched off your camera? Jagannath. Hiren Reddy, you're still in you're coming back from your coaching?
My camera is shut every time. I do something right. Only Sunday, Saturday, something.
Okay, no. So this is G, right? So now G is what? The dimension for G is,
Constant.
I have to write dimension of this constant G. So it will be, how should we write? It is dimension of F multiplied by dimension of R square divided by dimension of M1 multiplied by dimension of M2. Clear? Simple, we are doing the cross multiplication. From here, can you get G as FR square upon M1, M2? All of you.
Yes, sir.
All of you, yes or no?
Yes,
यस.
sir.
Yes, sir.
Yes, sir.
So we have FR square upon M1, M2, right? तो अब यहां देखो कैपिटल F. What is dimension for capital F? Anya, what is dimension for capital F?
Sir, it is L1 into M
Into
L1 into M1.
or
Yes, sir.
और बेटा तुम ये क्लास में सो रही हो तुम आज क्या?
No,
3
sir.
बार भी बता चुका हूं मैं यही तुम्हें आज. आन्या,
Yes, sir.
ये तुमने नहीं पढ़ा अभी?
Sir पढ़ा है.
फिर तुम इसको ये याद नहीं रह सकता है, या कॉपी में देख के नहीं बोल सकते हम लोग इसको? m⁻1 l⁻1 t⁻−2 ये समझ आया था बेटा या नहीं आया? हाँ ना बोलो।
Sir आया था.
हाँ तो फिर याद रखना, ठीक है? नहीं याद है तो कॉपी में देख के बोलो, पर कम से कम अभी याद किया उसको रिकॉल तो करो। So it is ml t⁻−2. All of you agree to this or not? This is dimensional formula for mass.
Yes,
Yes.
चलो,
sir.
Yes.
ईशान प्रसाद,
Yes,
ईशान,
sir. Yes,
what
sir.
is dimensional formula for r?
Sir,
R is the distance between the two masses. So distance का unit is what?
sir,
Distance का dimension.
sir, for distance, sir.
Yes.
For distant meters.
So meter is represented in length, right?
Yes, sir.
So length power 2, right? All of you, yes or no?
Yes, sir.
Yes, sir.
Yes,
M1
sir.
is M1 is mass, so M. Capital M2 is mass, so M. So now this M cancelled out. We have m⁻−1 l⁻1 into, sorry, not l⁻1, it's l⁻3
Power 3.
into t⁻−2. So finally we will write it like this: m⁻−1 l⁻3 and t⁻−2. I hope all of you understood this. Yes or
Yes.
no?
Yes,
Yes,
sir.
Sir.
Any
Yes,
doubts?
sir.
Any doubts till this point?
No, sir.
No, sir.
No, sir.
No, sir.
लिखो इसको जल्दी से. Note it quickly. Then we will do one more example based on this.
Done, sir. Done, sir.
Done, sir.
Noted all of you?
No,
No,
sir.
sir.
No, sir.
लिखो लिखो
Sir, 1 minute, sir.
आराम से लिखो, गलती नहीं करना बस.
Finish. Done, sir.
Okay.
Done, sir.
Done, sir.
Done, sir.
चलो. Shall I move ahead? Anybody who is still writing? कृषा हो रहा है बेटा?
हाँ, sir.
ठीक है, समझ आ रहा है ना?
Sir.
ईशा, you understood?
Yes, sir.
विहान, विहान तोले,
Yes, sir.
Yes,
विहान
sir.
वर्मा,
Yes, sir. Understood.
आन्या शर्मा,
Yes, sir.
अन्वी,
Yes, sir.
मनोगना,
Yes, sir.
मिस्टर जगन्नाथ.
Yes, sir.
ओके, ठीक है. So let's move ahead to next example in the same domain, right? So all of you have seen pendulum. Have you guys seen pendulum? All of you?
Yes, sir.
sir.
Yes, sir.
नहीं देखा है? किसने नहीं देखा है?
देखा है सर।
तो देखो, पेंडुलम नहीं देखा है तो प्लीज अपने फिजिक्स लैब में जाना और वहाँ वो जो रहते हैं सर, लैब असिस्टेंट, उनको बोलो, ही विल हेल्प यू, लैब इंचार्ज जो होते हैं। तो देर इज अ बॉब, एक छोटा सा गोला होगा आयरन का, देर विल बी अ स्मॉल आयरन बॉल, iron or lead ball, whatever, and it has mass, some mass m. There is a string, it is suspended through a string from a fixed point. The length of the string is L, right? Now, there is a term called as acceleration due to gravity. There is a term called as acceleration, it's a vector quantity, acceleration due to gravity. How many of you are aware of this term? Achha, how many of you are not aware of this term? Type I in the comment. If you are not aware of this term, please type I in the comment. Okay. So there are many. Okay. Agreed. So please pay attention. So when an object is kept on Earth, all of you please pay attention. When an object is kept on Earth or on the surface of Earth, you can say, right? This mass is small m. Mass of Earth is capital M. The distance between the two center of Earth and the mass is radius of Earth, capital R. Okay, all of you understood?
Yes, sir.
Sir, that black box is the pendulum ka ball.
बेटा वो मास है, मास ऑफ ब्लॉक ऑफ मास m, एक छोटा सा ब्लॉक है। मैं अभी तुम्हें जी समझा रहा हूँ। प्रणव,
अच्छा।
तुम क्लास में हो बाहर हो? You are in the class or you are outside?
Sir, I am in the class.
Okay, ठीक है। So just now we have learned about gravitational force of attraction, right? Just now we have learned about gravitational force of attraction. Yes or no? And that
Yes,
is
sir.
G
Yes, sir.
capital M small m upon R square.
Yes,
Right?
sir.
अभी पढ़ा है ना हम लोगों ने। The distance between the two masses, center to center लेते हैं. So from center of the earth to center of the block. So it is GMM by R square. Because of this, all of you are aware that we say that this block will be attracted towards the center of earth. The block is attracted towards the center of earth. Yes or no?
Yes, sir.
Yes, sir.
Now, always remember, this force can be given as, so if we magnify it, let's say this box is kept in your room, on the floor of your drawing room, right? This box is kept on the floor of your drawing room. So this is the box. And we know that the gravitational force acting on the block is GMM by R square. There is another way to write this entire force. And we write it as M into G. Small m into G. You guys are aware that every force will bring in some acceleration. Yes or no? Mass into acceleration. Hota ya nahi?
Yes, sir.
Yes, sir.
Yes.
Anybody who does not know force F is equal to mass into acceleration? Anyone who is unaware of it? Force F is equal to mass into acceleration. Pranav, you're not aware about F is equal to ma?
No, sir.
You are in which standard, Pranav?
7th.
7th.
Yes, sir.
Oh, so then you will not be aware. So Pranav, whenever there is a force, always remember this. Whenever there is a force acting on an object, right? It
Yes,
brings in an acceleration to that object. Okay, suppose there is a block of mass m. Pranav, pay attention. Suppose there is this block of mass m and we pull this object with a force capital F, right? So this force will bring in an acceleration to this particle, and that is given as F is equal to ma, or A is equal to F by m. Understood?
Yes, sir.
So here in this case also, since we have a force acting on this block, the black box, we are equating it to mass into acceleration. All of you understood this?
Yes, sir.
Yes, sir.
M cancelled out. So we have A as G capital M upon R square. We have it as G capital M upon R square. Understood, all of you?
Yes, sir.
Yes, sir.
This acceleration
Yes.
is, in gravitational terms, is denoted as G. And this is called as acceleration due to gravity. Acceleration due to gravity. I hope all of you understood this.
Yes, sir.
Yes, sir.
So
Yes,
we
sir.
found this G, right? We found the capital G. Yes or no?
Yes, sir.
Yes, sir.
तो क्यों लिख रहे हैं उसको, वो important है. So capital G का dimension is this dimension, or it is FR square upon M1 M2, right? Capital G is, okay, let's write it this way. It's, नहीं, दोनों में से कुछ भी लिख सकते हैं ऐसे तो. Anyways, M power -1 L cube T power -1. So it's M power -1 L cube into T power -2. This is dimension of G, yes or no?
Yes, sir.
Then
Yes.
dimension of M is M. Mass is, dimension of mass is M only, right? Divided by, this is L square. R is radius. Radius is measured in meter. Dimension of R is L square. Clear है यहाँ तक? Everybody understood this or not? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Now this is, we cancel this. We cancel this. What do we get here? L to the power T minus 2. Yes or no?
Yes, sir.
Unit is meter per second square. Yes or no?
Yes, sir.
Yes, sir.
Yes,
That's
sir.
why we call it as acceleration due to gravity. Whenever a gravitational force acts on an object, it brings in an acceleration because of gravity in it. And that is why this term is called as acceleration due to gravity. I hope all of you understood this.
Yes.
Yes, sir.
Yes,
Anybody is
sir.
having any doubt, please ask. Anvi, समझ आ रहा है बेटा? Anya,
Yes, sir.
Nilab,
Yes, sir. आ रहा है, आ रहा है.
okay. Please note this first. इसको लिखो पहले. All of you write this. विहान,
Yes, sir.
दोनों विहान को समझ आ रहा है कि नहीं आ रहा है?
Yes, sir.
Okay. If you have noted it, please type done in the comment window or just tell noted. Done. पर बेटा समझ के लिखना, वॉट एवर यू आर राइटिंग प्लीज अंडरस्टैंड इट फर्स्ट। हाँ, दैट्स व्हाई आई एम एक्सप्लेनिंग दिस टू यू। जहां नहीं समझाना होगा वहां मैं मना कर दूं, ठीक है, बट दिस इज व्हाट यू कैन इजिली अंडरस्टैंड।
Done, sir.
चलो, shall I move ahead from here? Anybody
No,
who is still writing it?
Minute, sir.
no, sir.
अनवी हुआ?
No, sir, 1 minute.
लिखो लिखो, जल्दी लिखो।
Done, sir.
Done, sir.
Okay, okay,
Done.
एक
Done,
मिनट।
sir.
हम्म, ठीक है। So now coming back to our example, what were we doing? We were trying to find the dimensions of physical constant or coefficient. This is second example in that, right? This is second example in that. So, beta ध्यान से सुनना, all of you please pay attention. The time period of this simple pendulum, this is called as simple pendulum, a small bob of some mass, and it is hanging by a string and it is just oscillating about its mean position, about a point, right? For small oscillations, always remember, for small oscillations, there is this time period. So time period of a simple pendulum. What do you understand by time period?
The time taken to
Time
complete
taken to
Time
complete one
taken to complete
oscillation.
one oscillation.
yes.
Pranav, you understood time period? What is time period? Pranav,
Yes, sir.
you understood time period? It is time taken to complete one oscillation. So this pendulum will start from this point. Let's say from this point, it goes to this extreme, right? This is positive extreme. Then it comes back to negative extreme, right? And then it comes back to the mean position. So this is how it completes one oscillation. So to complete this oscillation, the time period capital T, all of you please pay attention, is proportional to is proportional to
Sir,
एक मिनट, is equal to, let's say, some constant. अच्छा, इसको एक कर लेते हैं, इसको ऐसे ही कर, is proportional to root of
1/G.
L, length of the pendulum, and inversely proportional to root of acceleration due to gravity. The constant is some constant k, which we don't know. This is root of L upon root of G.
Yes, sir.
Right? All of you understood this? हाँ नीलाभ, तुम कुछ बोल रहे थे, क्या पूछ रहे हैं, बोलो।
सर आपने वो टाइम पीरियड के नीचे क्या लिखा है?
टी लिखा
उसको वो पूरा
ये
उसके नीचे
रूट एल।
तो एल वो इफेक्टिव लेंथ होती है क्या सर?
अभी तुम सुनो ना बेटा, इतने लेंथ ऑफ द स्ट्रिंग है इधर, ठीक है।
ओके।
एल लिखा है ना बेटा, इस लेंथ ऑफ स्ट्रिंग मैंने मेंशन किया ना यहाँ पे,
ओके
तो यही लेंथ होगी,
ओके।
ठीक है।
क्योंकि
हाँ
सर वो हमें
नहीं
स्कूल
नहीं,
में बोला था इफेक्टिव
अभी रुको
लेंथ है।
ना, नहीं नहीं बेटा सुन ना मेरी बात। उन्होंने कुछ पढ़ाया है, कुछ बोल के सिखाया है, यहाँ पे हम कुछ अलग, मैं मेंशन कर रहा हूँ लेंथ ऑफ द स्ट्रिंग है
ठीक है।
सब। अभी
ओके।
हमको उतना ही रखना है, ठीक है।
ठीक है ठीक है।
हाँ
सॉरी सर।
नहीं नहीं, अरे सॉरी मत बोलो भाई, सुनो बस।
सर
तो दिस, हाँ बोल।
सर दैट वो जो बॉब है, वो
हम्म
जो ऐसा पॉइंट पे जाता है, ऐसा स्विंग होके, वो फारदेस्ट पॉइंट भी लेंथ में ही कैलकुलेट होता है कि वो अलग होता है?
ये क्या होता है मुझे नहीं पता, लेंथ क्या होता है तुम्हारा। लेंथ, लेंथ ऑफ द ये स्ट्रिंग है, ठीक है, ठीक है।
अच्छा
हाँ
ठीक
ईशा।
है।
So what is that K, sir? Constant.
It's some constant. We are not aware about it. Just like we had this G here,
Ah,
same way we have L, K here. We don't know. So we have to find the dimension of this K.
okay.
Got it? Isha,
Got.
hello? Isha, you understood or not?
Yeah. Yes, sir.
This, हाँ. So K is equal to time period T, root of G upon root of L. ठीक है? K is equal to time period T, root of G upon root of L. Now what is time period? Time is denoted as capital T only. Yes or no? Hello.
Yes, sir.
Yes,
Hello.
sir.
Yes
Time
sir.
is denoted as capital T only. So T to the power 1. Now, what is this G? G is meter per second square, right? So it
Yes, sir.
is, meter is L, T to the power minus 2, power 1 by 2. Yes or no? All of you.
Yes, sir.
Divided by, yes Anya?
Sir, how did you get K is equal to T root G upon root L?
क्रॉस मल्टीप्लाई करना आता है बेटा? y by x is equal to a by b लिखूं अगर मैं, तो तुम a को by अपॉन x लिख सकती हो कि नहीं?
Yes, sir.
ये पढ़ा है ना तुमने मैथ्स में कि नहीं
हाँ,
पढ़ा? तो वैसे ही
sir.
लिखा मैंने यहाँ पे, t इज इक्वल टू k रूट l बाई रूट g है, तो k क्या हो जाएगा बेटा?
Sir, but root G को equal के left side नहीं होना था.
क्यों? क्रॉस
Be-
मल्टीप्लाई करके अगर मैं k को लिखना चाहता हूँ इनके टर्म्स में, तो क्या प्रॉब्लम?
Okay, sir.
ठीक है। देन दिस इज रूट ऑफ l, सो l इज लेंथ, l टू द पावर 1 बाई 2. आई होप ऑल ऑफ यू अंडरस्टूड दिस. यस और नो?
Yes, sir.
Yes.
Yes,
नाउ
sir.
लेट्स ट्राई टू सॉल्व इट. So this is t to the power 1 minus 2 power 1 by 2 will be minus 1. So t to the power minus 1 into, when I open this bracket, it is L power 1 by 2, and this is L power 1 by 2. This cancels out with this cancels out with this. So we get K as, what is K now? It's a pure
One.
constant. नहीं नहीं, 1 नहीं, is a dimensionless quantity which does not have any dimension, is called as dimensionless quantity. Understood?
Sir, but all wheel cuts will get one, no?
हाँ तो 1 आया तो डायमेंशन नहीं मिला ना मुझे कोई.
अच्छा समझा।
क्या मिला मुझे यहाँ पे? देखो इधर आओ सब लोग, ऑल ऑफ यू पे अटेंशन. वी डोंट हैव एनी फंडामेंटल क्वांटिटी इज नॉट कमिंग हियर. एम एल टी जीरो, करंट वरेंट तो आएगा ही नहीं. तो व्हाट इज दिस? दिस इज अ, के बिकम्स अ डायमेंशनलेस क्वांटिटी. अंडरस्टूड?
Yes sir.
तो इट कैन बी एनी कांस्टेंट, 2 3 4 5 6 7 8 9 10, 10 टू द पावर माइनस 1, कुछ भी हो सकता है ना ये.
Yes, sir.
So in case of these type of cases, when we encounter these type of cases, we find the value of k using, experiments. So value of k is determined by experiment. You will take a stopwatch, put this bob aside and then release it. You will count it for 20 oscillations, note the time period, and note the total duration of 20 oscillations, divide that 20 oscillations, divide the time period by 20 oscillation, you get the time period of one oscillation. So that is a experiment which is performed. Understood?
सर k की वैल्यू 2 पाई होती है ना?
हाँ होती है 2 पाई, वो एक्सपेरिमेंट से निकल के आता है, पर वो डायमेंशनलेस होता है, कैसे होता है वो प्रूव कर रहा था. ठीक है? All of you understood this or not?
Yes, sir.
Anybody is having any challenge in understanding why this is written here, why this is written here? नहीं समझ आ रहा है तो पूछ लो भाई, और अगर समझ आ गया है तो उसको जल्दी से लिख डालो फटाफट.
Done, sir.
Done.
Okay. Sure. So if you have noted it, anybody who is still writing?
Sir, I am.
Okay. Isha, you understood? Isha, Khyati,
Yes,
Dhiren Reddy, Jagannath,
Yes, sir.
Manogna,
Yes, sir.
Vihan Tole.
Yes, sir.
Yes, sir.
Okay, Mishika.
Yes.
ठीक है. So homework for all of you. Just pay attention. I'll send you the recording, don't worry. Homework for all of you. Can you see this chapter here? Worked out examples, page number 7. All of you, please pay attention. Worked out example, page 7 of H.C. Verma. Do this question number 1. Now, all of you pay attention. You may not understand what is surface tension. You might be hearing it for the first time. Google it, what is surface tension? Try to find it out what is surface tension, and then write the formula and then do it. Now, if you don't want to do it like that, if you don't want to Google it, at the end of this book, in appendix, can you see this? In the end of this book, every H.C. Verma has this, every volume. Here all the values are given. All the, देखो, surface tension is given here. Can you see this surface tension? It's N upon M, right? यहाँ पे देखो, यहाँ जाओ, ये क्या है? इसको बोलते हैं इंडेक्स. इधर देखो सब लोग, इंडेक्स में जाओ, एस ढूंढो, एस कहाँ है? सरफेस टेंशन यहाँ पे देखो, यू विल गेट इट हियर. कैन यू सी दिस हियर? सरफेस टेंशन. हेलो.
Yes, sir.
Yes, sir.
ओके, तो ये वहां जाओ और ढूंढो, तुमको मिलेगा. फ्रॉम हियर यू कैन ट्राई राइटिंग. ओके, यू जस्ट हैव टू नो द फॉर्मूला. कहाँ से आया, क्यों आया, कैसे आया, इससे कोई मतलब नहीं. You just know the formula that this is how surface tension is written. For example, surface tension is given as force per unit length, F upon N. So you have to know only this formula. Now you write dimensional formula for this. Understood?
Yes, sir.
Dhiren Reddy, Jagannath, what you have to do? You understood or not? How to move ahead
Yes,
in
sir.
this?
yes, sir.
These terms are new to you. You will not be able to understand how, why, don't just know the formula that this is how it is written. I have to write. Your objective is to write dimensional formula. That's it. If you'll not be able to do it, I'll help you doing it. Don't worry, right? But try to maximize it. So the questions which you have to do today. एक second, huh? The questions which you have to go do is introduction to vectors physics. ये देखो इधर. Question number 1, 2, 3. Question number 1, 2, 3. Exercises. Question number 1, question number 2. Exercises में question number 1, 2. 3. इतना कर लो, देखता हूं तुम कितना दिमाग लगाते हो. देखो मैं फिर कह रहा हूं, you are not aware about any technical terms of physics as of now, I understand, but you can always find the relation, you can always find the formula for it. How to find it, I have already told you. See, at the back of the chapter, at the end of the book, you will find an index. There you can go and look for that कि कहाँ है वो. This is how you'll know how to find any term in this book, right? Try doing it. देखो, I would have given you some easy example, easy questions also, पर easy का कोई मतलब नहीं है. Try doing it. You'll come across few more new terms, right? You'll learn about those new terms, at least a relation. So let's see how you do it. ठीक है? So first 3 questions of exercise, first 3 questions of solved example. That is what you have to do. Try doing it. If you are not able to do any of them, don't worry, I'll help you do them. But any of तो होगा ही नहीं. You'll be able to do some of it comfortably. For some, you have to do research and look into the textbook. ठीक है? करो.
Yes, sir.
We are meeting on Saturday. You have enough time. Look into it, and then we can move. ठीक है? Or you can connect with me in the WhatsApp if you're finding it difficult. Bye.
Yes. Bye, sir.